See, voltage source inverter fed synchronous motor drive, that is the next topic. Now see, you know the operation of the synchronous motor and you know the operation of the voltage source inverter. We have been using this voltage source inverter even in the power electronics course. Then in the induction motor case also we have studied that okay, voltage source inverter is there either with the help of the IGBTs or with the help of the thyristors. With the help of anything, okay, we can design a voltage source inverter. And by controlling the firing, for example, if it is thyristor, by controlling the firing angles of the thyristors, we will get different voltages and different frequencies. Okay, it depends upon that. We can control the speed of the synchronous motor. See, it's very same, except the controlling terminals are different in case of the synchronous motor than in case of the induction motor. So that is the only difference, but the operation of the inverter is same even in case of your synchronous motor also. Okay, so that part of that I don't want to explain. Okay, we'll just I hope the circuit diagram also you know very well. What is circuit diagram of that? So I will just draw the circuit diagram. So it's a three phase, so you will have three similar phases like this. Okay, so I'll do one thing. Rather than drawing these many number of times, so we'll do one thing. So this is the three phases. So these are the three phases. I know that you know the switching sequence. You know the switching sequence. Okay, so one, two, three, six. So the voltage, three-phase voltage source inverter you have studied already. So there is no point in discussing here. So now you have DC supply here. Okay, then we will take the AC from the three. So all the three, okay, will go to the in the synchronous motor, stator or the armature of the synchronous motor. Okay, all the three supply goes there. And then by changing the switching sequence, like how we did in case of your induction motor, same procedure is there, and there is nothing else is there here also. The same kind of operations we have used there. Okay, so you will get the same voltage output voltage also there. And you know, so but one thing is there. So this is only the power circuit which I have drawn. But coming to the entire block diagram, there is a little bit different is there. Small difference is there, not much. Okay, there is only small difference is there. It depends upon what type of controlling you are using. So this is the power circuit, just a power circuit I have drawn. Okay, so if we go to the control circuit or if we go to the entire circuit, we go to the entire circuit, we have different ways we can do that thing. Okay, see this now I will draw the diagrams which we require for all the possible cases. Okay, so see now. So this is very common. Means how you give the supply. This is three phase AC. The next block is in rectifier. Okay, and this one is for rectifier. It is inverter. Oh, once again, so the inverter is the voltage source inverter. You can take it as voltage source inverter. Okay. So the output of the inverter goes to the motor. That we know. This is L. Okay, this is C. So this is the very common circuit. You have supply and you have rectifier, then you have filtering, then you go to the inverter, then after that it goes to the synchronous motor. Now we'll take this. Now please see this now here. So now using the voltage source inverter, we can see different types of block diagrams we will get here. Yeah, please answer, is the screen visible now?
Yes,
Please
sir.
answer.
Yes, sir.
Is the screen visible?
Visible, sir.
Anyone please answer, is the screen visible?
Yes, sir. Visible, sir.
Okay, thank you. So then see now. So this is the power circuit. The left side one which I have drawn here is the power circuit. This is the power circuit. So voltage source inverter fed synchronous motor drive. Okay, so now you see, so it's a voltage source inverter that is made up of thyristors. So by changing the switching sequence, we will get different frequencies and different voltages. So the operation of the voltage inverter is same even in the case of the induction motor also. So that part we are not going to discuss here, but we'll discuss about the closed loop controls now. The closed loop controls of this. So we have seen last class itself that two types of controls are there: separate control and self control for your synchronous motor. So I told you already, separate control is nothing but the open loop control, whereas the self control is nothing but the uh, closed loop control. This we have already got that. So now first we will see this is separate control, separate control, separate control of synchronous motor fed from square wave inverter. Okay, I hope you know what is. See, this is now this diagram which I have drawn now. Of course this is some more part is there. Okay, this where it goes to the synchronous motor armature. Okay, then you have the field here. This is the field. So now this is the voltage setter. Okay, so this is speed from oscillator. So now what is this block diagram says is that first of all you need to know few things, that what is a square wave inverter. So this is important. You recall in the voltage source inverter, In the voltage source inverter, you get this waveform directly. For example, if it is 120-degree conduction, then you will find out this for one phase. This one. Similarly, for the remaining two phase also you will get. So what is this? What is these waveforms? These waveforms are nothing but squares. So these waveforms are square. So square waves you got here. You got the square. So this voltage will be here. This voltage will be here. So separate control of synchronous motor fed from a square wave inverter. So the inverter here, it works as square wave inverter. And one more thing is that it is a controlled rectifier. It is a controlled rectifier. It's a control rectifier. So whereas this inverter, based upon this voltage VDC, so the height of this one is VDC. The height of this one is VDC. So based upon this VDC, it will generate a voltage like this. That's it. It will generate a voltage like this. So here you cannot expect any kind of control in the inverter block. Whereas here you have the this controlling part here. So what you do here is that how it. So why we are calling first of all it is square wave inverter is that the output here is a square wave. The output here is a simple square wave. So you give, so the pulses will be generated here, and as per the pulses you will get this thing. So now what is this feedback here is that the speed from the crystal oscillator. So I hope you know what is an oscillator. So so you can say like this, that oscillator, it generate pulses. So those pulses will go to the uh, switches here in the thyristor, the switches in the inverter. So to those you will get the pulses. So how you will get is that there is a voltage setter will be there. So this voltage setter, okay, will generate both. It will generate the pulses here, and also it will generate the pulses here. Now the pulses here you can vary, whereas the pulses here you cannot vary, and is a fixed value. Okay, so that is as per the design. Okay, so this is square wave. So let me explain the other one so that you will understand the difference between this part and the other part. Okay, so as per the circuit diagram, the power circuit is there and there is a feedback circuit is there. And this is the separate control. This is the block diagram for the separate control. And the inverter here is the square wave inverter. Okay. Now we'll go to another one. So this part remains same. Okay. So now remember this time, what is this? What is this block diagram? Is that it is also separate control. It is also separate control of synchronous motor. Now it is fed from PWM inverter. Earlier was the square wave inverter, now it is a PWM inverter. So here you can take sinusoidal PWM or any kind of other or multiple PWM. So any kind of PWM technique you can involve here, and so that we have the advantage already. Okay, so in this case, it's a very simple thing. Okay, so here you have, so the pulses you will give here, the pulses you will give here from the PWM, using the PWM technique you will give the pulses here. So this is the speed. So you will set the speed as per the speed, So you will set the speed outside. Remember, now you will set the speed outside. So that is in your hand, directly in your hand. So just like regulator, you have the regulator. So here also same thing. Here also same thing. Okay. So you will set the speed here also from the regulator, just like in your hand. Here also you set the same thing. Then after that, based upon that speed, here you control the rectifier, whereas it's a diode rectifier. Now there is a difference here. It's a diode rectifier. So if it is a diode rectifier, then the output voltage is fixed now. You don't control the output voltage of the diode rectifier. It is fixed now. So whereas this voltage comes here, then here you change the firing angle using the PWM technique. Using the PWM technique, you will just change here. So using the PWM technique, you can vary that. So based upon how much speed you set here, the width of the pulses that are going to the inverter will vary. Okay, so now one more thing, this remains same. Which one? Okay, this goes to the armature of the synchronous motor, whereas this is the field winding. Okay, so this is the synchronous motor. So that common is there. So you see the circuit diagram difference between these two. What is the difference you find out now? One difference you will find out. Here you are using the control rectifier, here you are using the diode rectifier. So as it is control rectifier, the firing angle to the firing angle to the rectifier, or the thyristors of the rectifier, based upon the speed how much you set, based upon how much you set. So the voltage here is a variable one. We can say the VDC here is a variable one. It's a variable one. Whereas here it is a constant. Why it is a constant? It is constant because it's a diode rectifier. Whereas once you see here, as it is variable, you vary the firing angle here, then this VDC will vary. Then as per that this varies. Then as per that the properties of the synchronous motor will vary here. Whereas the to this inverter, the pulse width you don't change, because once you have changed here, that's enough. You don't want to change here. You don't require to change here. It is changed here. That's enough. Then that value will go here and it will do. Whereas in this case, whereas from the PWM inverter, the second case, what do you find out is that this voltage is constant. So you cannot do any changes here. So this voltage is constant. Now what you change here is that the width of the pulses that are going to the inverter. So you control the inverter here. In this case, you don't control the rectifier here because it is a diode rectifier. So you control the inverter here using this PWM technique, and the speed is set by you. Here also speed is set by you. Okay, in both the cases, speed is set by you. Only difference is that here the diode is a uncontrolled one, whereas the previous case the diode is a controlled one. So the output voltage of the rectifier is variable in the previous case, whereas the output voltage of the rectifier here is constant. Okay, so then after that, the previous case is a square wave inverter, whereas this is the PWM inverter. So you can control the inverter using PWM, different PWM techniques, sinusoidal PWM technique, multiple PWM technique, whereas the previous one is the only square wave. And both the cases are separate control. It's very important. Both the cases are separate control. So you set the speed yourself. You set the speed, so you set just like regulator. So you connect the, you just vary the regulator. Then as per the thing, the speed of the fan will change. So it's a open loop path. It's not a closed loop path. Okay. So separate control in the sense what? Separately you are controlling the speed. You are going there and you are controlling separately from outside. That's called separate control. Then you have another block diagram. Okay, this one. So this one, what is this one? I will write here. It is self-control. Self-control fed self-control of synchronous motor fed from square wave inverter. Here also square wave inverter. So if it is square wave inverter, by this time you must know that this should be a controlled rectifier. This should be a controlled rectifier. Okay. Whereas this firing, this is fixed now. Means this is variable, so this voltage is variable now. So whereas the pulses going to the inverter, they are fixed now. They are fixed now. So you don't vary the, you don't control the inverter here. So the pulses going to the switches of the inverter, they are fixed now. So you don't do any changes here. Okay. Whereas this, remember now, square wave inverter in the sense you will have the control rectifier. So the thyristors of this, okay, their firing angle will vary every time. Okay, they are varying every time. So here you generate the firing angle. Now here the pulse width, it remains constant. You don't change. So based upon which parameter, you vary the alpha here. That is the next question. So how do you vary that? Is that so before that we'll just complete the circuit diagram. So it goes to the armature of the synchronous motor. Then you have the field winding. So this is a synchronous motor. So what you do here is that in this case the speed is there. You take the feedback from, so this is the, I will take speed feedback. This time you take the actual speed. You take the actual speed. So here you have, okay, this is reference speed. Here you have reference speed or set speed. You will set that. Then after that you compare with the actual speed. So there is a speed feedback is there. There is a speed sensor is there. Okay. So based upon that, alpha values will be released. Alpha values will be decided, and based upon that, the value here is changing every time. So that changing value will come here. Then the inverter will produce the square waves to the armature of the synchronous machine or synchronous motor. So here you are taking the feedback here. That's very important. So why you are taking the feedback is that every time this actual speed will be compared with the reference speed. So this is a closed path. You can call it as closed path. Now you see this closed path you don't find out in the previous two controls. So those two are separate control. So the speed is controlled separately, whereas the speed here is controlled. It's a self-control. So there is a feedback is there. Every time you compare with the speed, then as per that it will come. Every time you take the feedback from the rotor of the synchronous motor, that is the field. Okay, so then you compare with the reference speed. Then as per that, as per the error, alpha will be generated. So every time it changes. So the controlling is here in this path. Okay, in case of the square wave inverter. Now there is another one. There is another one. Okay, this is the last one. So this one is self control of synchronous motor fed from PWM inverter. So now this is a diode rectifier, just like the previous case also. Whereas you see here now, so it's diode rectifier, this is fixed now. So you don't control anything, but you control here. Your inverter, you control now this time. So how do you do that is that, let me complete this picture. This is your synchronous motor. So you take the feedback here, feedback. See, remember self-control in the sense you will take the feedback. That is, and you compare with the reference speed. Minus plus. Then the error, based on the error, the controller will produce the pulses required for this. Okay, required for this. So based upon that, it control the pulses required for the. So using PWM technique will generate the pulses. So what is the input to this PWM technique is that the error between what, the actual speed and the reference speed. Okay, it's a. So this is it. Okay, this is about your self control. So just I will summarize the differences between all the four. See, two types of controls are there already in your synchronous motor. So separate control and self control. You see the first separate control. In the separate control, you are not taking any kind of feedback. Just see this now. There is no feedback here. There is no feedback here. You are not taking the speed feedback, but rather you set the speed. That is, you go to the fan regulator, you set to position number 4, and you really never know that whether as per the position 4 the motor is running or not. That you don't know. Only thing is that you will feel yourself that whether it is running with high speed or whether it is running with low speed, but you don't know accurately what is the speed of the synchronous motor there, because you are not taking the actual speed feedback in the separate control. In the separate control, you have two types of inverters: square wave inverter and PWM inverter. In the square wave inverter, so what you do here is that the inverter pulses you just don't change. Which pulses you change here? In case of the control rectifier, the thyristors are there, so thyristor firing angles you will change here. But here you don't change anything. So the rectifier you will use in the case of the square wave inverter. In case of the square wave inverter, the rectifier you will use is the control rectifier. You see here, and also you see even in case of the self control also. If it is a square wave inverter, you are using the control rectifier. Whereas if it is PWM inverter, you are using that here also diode rectifier. You see here also diode rectifier. So in case of the PWM inverter, directly you control the firing angles or the pulses going to the inverter. Whereas in case of the square wave inverter, you will change the firing angles of the rectifier. See here, rectifier controlling and inverter controlling. Okay, separate control, self control. You see several ways you can classify this. With these 4 block diagrams, you can classify several ways. Okay, so what are the ways is that Okay, what are the ways is that separate control in the sense you will not take the feedback actual speed you don't measure, whereas self control in the sense you measure the actual speed you see here. Then once again you have another category. What is that category? Whether it is a square wave inverter or whether it is a PWM inverter. If it is square wave inverter, if it is square wave inverter, so the output voltages of the inverter are just square waves. Whereas if it is PWM inverter, you know the shape of the waveforms will be slightly changed. Of course, there also you'll find out the square waves only, but you may have more number of pulses sometimes, or you may have stepped waveforms. Okay, so because so why we go for the PWM technique, already you might have studied that we go for the PWM technique mainly for the reduction of harmonics, that is the output voltages. To reduce the harmonics as much as possible, we will go for different PWM techniques. So in case of the square wave inverter, okay, so the inverter you generally don't control, rather you control the rectifier in case of the square wave inverter. Whereas in case of the PWM inverter, you see the rectifier is the uncontrolled one, diode rectifier. But the controlling will be on the inverter by changing the firing angle with the help of PWM techniques. So total possibilities are four. So two variables are there. One is separate control or self control. The other variable is whether the inverter is a square wave inverter or PWM inverter. So then you will have four possibilities here. You have four possibilities here. Okay, so all the four possibilities we have seen here. So you see the feedback is only there in case of your self control. So then you must understand the difference between the self control and the separate control. Okay, and the power circuit remains same. I don't need to explain that how the rectifier works, and I don't need to explain that how the inverter works. These topics we have already studied in the previous semester, and also this semester also, while I'm explaining the induction motor control, there we studied briefly about this inverters, current source and voltage source inverters. All these things also we have studied already. Okay,